In this video, we're going to be taking a look at the process of bypassing UAC or user account control on Windows for the purpose of privilege escalation or elevating our privileges with a tool, a really cool tool called UACMe. So before we actually get started with using UACMe and bypassing UAC, we need to understand what user account control or UAC in Windows is and how it works and how this privilege escalation vector or vulnerability works. So user account control is a Windows security feature that was introduced in Windows Vista that is used to prevent unauthorized changes from being made to the operating system. And UAC is used to ensure that changes to the operating system require approval from the administrator or a user account that is part of the local administrators group. So if you've used any version of Windows from Vista onwards, you know of the following prompt here, where you can see it tells you that do you want this app to make changes to your device, even if you're an administrator or part of the local administrators group. So the bottom line is, if I, for example, am running as a user that again is part of the local administrators group, my current privileges, or if I list out my privileges, will actually not reveal any of the privileges you'd associate with being an administrator. And the reason for that is UAC. So when you want to run something as an administrator or with administrative privileges, you need to specify that as such, which is again why on Windows you can right click and run something as administrator. Otherwise, before that or without doing that, you're simply running as the standard user and with the privileges of a standard user. This is again taking into account the fact that you might be a local administrator. So a non-privileged user attempting to execute a program with elevated privileges will be prompted with the UAC credential prompt. So let's say you're a standard user account that is not part of the local administrator group. Well, in that case, you'll not get this prompt, but you'll get one similar to this that asks you for the administrator credentials. I'm sure you've seen this before. That's very common in organizations where you need to provide a username and password, most likely for the administrator user. But if you are part of the local administrator group as a user account, then you will get this prompt here that just asks you to confirm that you want to run this app or a particular application with administrative privileges. So as it says here, whereas a privileged user will be prompted with the consent prompt, and this is the consent prompt right over here. So attackers can bypass UAC in order to execute malicious executables with elevated privileges. Now, the way this privilege escalation technique works, or the requirements for this privilege escalation technique, are firstly, you need to have access to a user account that is part of the local administrators group in order for any UAC or bypass UAC exploit to work in the context of privilege escalation. So as iterated here, in order to successfully bypass UAC, we will need to have access to a user account that is part of the local administrators group on the Windows target system or the system we have compromised. UAC allows a program to be executed with administrative privileges, consequently prompting the user for confirmation. And that's where the whole idea of bypassing UAC comes into play. So let's assume, you've gained access to a Windows system and you have access via a user that is part of the local administrator group. Remember, because as I just covered earlier, even users that are part of the local administrator group, meaning they have administrative privileges, will be running under the context of a normal user. Now, if we don't have RDP access, on the target system, or GUI access on the target system, and we have access, let's say, via a reverse shell or a meterpreter session, we cannot click on that prompt. So we can tell the Windows system to execute, let's say, an MSF Venom payload or an executable as administrator. But remember, we cannot physically click on yes on that consent prompt unless the user who is using the target system does that for us. It's probably not going to work. So the whole concept of bypassing UAC essentially ties into avoiding that consent prompt from actually showing up or requiring it in order to execute in order to execute, payloads or executables or commands with administrative privileges. So UAC has, as you probably know, has various integrity levels ranging from low to high. If the UAC protection level is set below high, Windows programs can be executed with elevated privileges without prompting the user for confirmation. So on Windows, you in the UAC settings, and you can check this on your own system, there'll be security levels for high to low that essentially allow you to configure UAC in the sense that you can pretty much get rid of that consent prompt. But again, that's just a little bit of a tidbit there. Now, there are many tools and techniques that can be used to bypass UAC. However, the tool and technique that you will use will depend on the version of Windows running on the target system and its UAC configuration. Now, I'm not going to be covering, Privesc via Metasploit modules around bypassing UAC, because that was covered in the eJPT courses. But more importantly, because of the fact that UACMe is pretty much the de facto standard when it comes down to bypassing UAC on Windows for privilege escalation. So what is UACMe? UACMe is an open source robust privilege escalation tool that's developed by Firefox, and it can be used to bypass Windows UAC by leveraging various techniques. And you can take a look at the GitHub repository, which we'll actually be going through when we get to that point. But the UACMe GitHub repository contains a very well documented list of methods that can be used to bypass UAC on multiple versions of Windows, ranging from Windows 7 to 10 and now Windows 11. And it essentially allows attackers to execute malicious payloads on a Windows target with administrative or elevated privileges by abusing the inbuilt auto-elevate tool. The UACMe GitHub repository has more than 60 exploits that can be used to bypass UAC depending on the version of Windows running on the target. So what I'm referring to here is that UACMe is facilitated through an executable called akagai.exe. And in order for you to bypass UAC, you need to specify a UAC bypass technique that are actually outlined on the UACMe GitHub repository. Again, don't worry, this will make sense when we get to when we actually take a look at the GitHub repo. But just keep in mind that UACMe allows for different techniques to be used, or allows you to use different UAC bypass techniques depending on the operating system that you're trying to bypass UAC on, or the version of Windows, I should say. Now, the best way to demonstrate this privilege escalation technique is to actually give you a demo of how it works. So this video has a lab associated with it, and it's going to be the lab just below this video. And you'll essentially be provided with access to a Kali Linux system, where we'll need to gain initial access first to the target, and then we can confirm firstly that we have access via a user that's part of the local administrators group, and secondly, we'll then walk through how to use UACMe, more specifically the akagai executable, and how to specify the correct technique, the correct UAC bypass technique. But that being said, let me fire up the lab, and I'll see you there in a couple of seconds. Alright, so I'm currently in the lab environment, and as you can see, you'll be provided with your target IP address. In your case, it'll be different for the reasons I've reiterated many times during this course, but we need to gain initial access to the target system first. So I'm going to copy the target IP. I'm then going to open up a terminal here, and we're just going to perform an nmap scan on the target system. So don't ping, disable DNS resolution, sync scan, and service version detection scan. And we're going to wait for this to complete. And we'll then identify the initial access vector, and we'll then gain initial access, and we can then proceed to, bypassing UAC. So this should be done any moment now. Alright, so the nmap scan is done. As you can see, we have the Regardé HTTP file server running on port 80. So that's going to be our initial access vector, similar to the previous video. So we know that this is vulnerable to command execution, or rather command execution vulnerability, and a module exists within Metasploit. So I'm going to fire up MSF console and search for the Regardé module. and I'm going to say use the module with the ID of 0, and we're going to set the rhosts option to the target IP like so, and we're going to use the 32-bit interpreter module, and the lhost and lport is already configured. We can now pretty much just hit exploit, and that should give us let's see if this works. That should give us a interpreter session. Indeed it does. So we are going to wait for that. There we are. And now we're going to say get user ID. So we're currently as the user called admin, and we then let me just say this is info. Let's perform some system enumeration. So Windows Server 2012, keep that in mind, as that is very important, specifically in relation to UACMe and the UAC bypass technique we choose to use. Another thing to note is specifically in the case of the user we have access to, I'm just firstly going to say, let me just migrate to another process like Explorer. So migrate 2408, and will then, I just want to highlight something very important. So first things first, I say get user ID. We're currently a user called admin. So you would assume that we have elevated privileges. If I say hash dump here, however, you'll see it doesn't work. Okay. Now, another thing that I want to show you is if I say open up a shell and say net local group administrators, you can see that the user admin is part of the local administrator group on the Windows system. However, if I say who am I priv, we would expect that this user is privileged or has all the privileges you'd associate with an administrator use. However, you'll see that we only have the standard ones you'd associate with a standard account, right? Now, the reason this is the case is, again, this pretty much comes down to UAC and the fact that in Windows or modern versions of Windows, you need to explicitly tell Windows that you want to run something as administrator, and only after you've done that, via the UAC consent prompt, does it allow you to execute something with the full set of administrator privileges. So the first check we have performed is, or the first requirement is satisfied. We are part of the local administrators group. And now that brings us to the actual process of bypassing UAC. So I'm just going to terminate that channel. And, if we try the standard get system command with interpreter to elevate our privileges, you can see that all of them failed. So, we pretty much are only left with bypassing UAC, which again is not as complicated as it sounds. Now, in the context of UACMe, there's a couple of things that I want to outline on the GitHub repo. But before we do that, we are going to need something or an executable or a payload to then tell UACMe or the Akagai executable to execute with admin privileges. So I'm going to I'm just going to open up a new tab here, and I'm going to create a payload with MSF Venom. So MSF Venom P, and I'm just going to, so MSF Venom P, Windows, interpreter, reverse, TCP, and then I'm going to specify the host. That's going to be our Kali Linux IP. So I'll open up a new tab here, and I'll say ifconfig, and I'll just copy my Kali Linux IP. Make sure to use your own in your lab session, and then the L port, we can just set this to 5555, not like the previous video. And then we'll say format exe, and we can just call it what we called it in the previous lab or video, which is just backdoor.exe. And let me hit enter, and that'll generate that payload. So now that we've generated our MSF Venom payload, one other thing I want to point out is that the UACMe, if you go navigate to your desktop on the Kali system under tools, you're going to see a folder called UACMe, and you're going to have the Akagai executable. So this is for all intents and purposes, the executable that allows you to bypass UAC. And in this particular case, I'm now going to switch over into the GitHub repo, the UACMe GitHub repo. And the reason for that is I first want to explain a couple of things, but just give me a second and I'll switch into my another browser tab here. Alright, so I'm currently in the UACMe GitHub repository, and you can see that you're going to have two folders, the binary folder right over here, and you're then going to have, let me take a step back here, there we are, and you're then going to have the source folder, which will essentially provide you with the source code for Akagai and the rest of the binaries here. So Akagai x64, x86, these are the main executable files. They contain the payload data or units. And then you have the other ones here that, again, you know, essentially provide you with different implementations of UACMe. But with that being said, in our case, we are going to use Akagai 64-bit because our target system is 64-bit. And that's because it contains all of our payload or data units. Now, you can see that the description says defeating Windows user account control by abusing the built-in Windows auto elevate backdoor. So in terms of the usage, what we are looking for is the method or the keys. All right. Now, these represent the privilege escalation, or rather the UAC bypass techniques that you can utilize depending on the operating system you're trying to bypass UAC on. And more importantly, you can see that for the first method, so method 1, it gives you the author, the type, so what type or how it's bypassing UAC, so DLL hijack, and you can see it works from Windows 7 build 7600, and unfortunately it was fixed. So we're looking for ones that haven't been fixed and fall within the range of the supported operating systems here. Now, in the case of this lab and our target system, the one we're going to be using is this one right over here, key 23 or method 23, which again, you can see right over here. It utilizes system32 package manager.exe, and the implementation, or rather, if we take a look at whether it's been fixed, you can see that it's currently unfixed, and it works from Windows 7 build 7600 onwards. So the lab has already provided you with a compiled version of Akagai 64, and you can see in terms of usage here that we simply need to run Akagai 64 and then specify the key or the method and then the executable we want to execute with administrative privileges, therefore or consequently bypassing UAC. So I'm now going to switch back over into the lab and we can get started. So I'm back in the lab, and in our Meterpreter session, I'm now going to navigate to a staging folder where we'll be uploading our backdoor, but also Akagai 64. So I'm going to navigate to the, we can go into the users and we can go into admin and into app data, you know, somewhere nice and secure that's not frequently accessed. Let's go under local and we'll go into the temp folder. Okay. First things first, let's upload backdoor.exe. And secondly, upload root desktop tools UACMe Akagai64.exe. And remember, we also need to set up our handler. So let's do that right now before we forget. So I'm going to say use exploit multi-handler. And I'm going to say set the payload to the one we used when generating it with MSF Venom. So I'm going to say Windows x64 Meterpreter, actually not x64, just a Windows Meterpreter reverse TCP, show options. There we are, and we're going to set the L host to our Kali Linux IP, which we have handy here. And the L port was 5555. Let me verify that firstly. Yes, so this time we set it correctly. And I'm now going to run this in the background so that we can interact with the current Meterpreter session. So now that we've done this, we can open up a shell session. And remember, we are going to be utilizing key or method 23. So we are going to say akaguy64.exe. Actually, let's verify whether they were uploaded into this folder. Yes, they were. So we'll say akaguy 64.exe, and then we specify the method or the key, so 23, and then we're going to say specify the path to the executable we want to execute with administrative privileges, therefore bypassing UAC. So admin, this was stored under app data and app data local, and the name was just backdoor .exe. And once we hit enter, we should get a second interpreter session with elevated privileges. So I'm going to hit enter, and we'll wait for a couple of seconds. Hopefully this works or worked successfully. That I know why that did not work. That did not work because I made a mistake with my spelling of app data. So we'll say actually I made a lot of mistakes there, so I'll just say C users instead of user, and then admin, and then app data, so uppercase A, uppercase D, local, and I forgot to include temp there. That was my mistake, and backdoor, but it should work. Backdoor.exe, hit it, enter now, and there we are. We get the second interpreter session. So I can now terminate this channel right over here, and I'm just going to put this in the background. And if I open up the sessions, you can now see we get a session, the second session with admin, again with the user admin here, but you'll actually see the difference in a few seconds. So I say get user ID. Yep, that's still the same. Nothing has changed there. But before we do anything, actually we can just type it in right now. If I say get privs, there we are. We now have all of the privileges that you typically associate with a user that again is part of the local administrator group or has administrative privileges. But what I want to do is let's migrate to LSAS. And I want to just verify that we have elevated our privileges. So I'll say hash dump. There we are. Fantastic. And we've successfully elevated our privileges and bypassed UAC with UACMe. With that being said, that brings us to the end of the practical demonstration section of this video.